in this example, I just want you guys to understand the imaging by a system of the optical devices, and to know how we can just trace in the right way. Okay, so we have lens and a mirror. Okay, so both of them are separated by distance equal to the 1 meter here. The focal length of the lens is the 80 centimeter, and radius of the curvature, no way, this is focal length, sorry, focal length of the convex mirror is 50 centimeter. So we have object a distance 1 meter on the left hand side of the lens, right? So now from the path A, we just want to locate the final image from by the light that has gone through the lens twice. Okay, and then find the overall magnification, and then image is upright or inverted. So now to understand this part, we need to trace the light. So we know that, the light will just come out from the object. So we'll pass the lens first. Okay, this is the first time we pass the lens. And then we will go to the mirror and then reflect it back. And then pass the lens again. And then form the final image somewhere here. Okay, so now you can see that if you pass the lens first and then reflect at the mirror and then pass the lens to be the second time. So now we need to calculate t times, right? To solve for the final image. Okay, so let's just look at the lens at the first time. Okay, we have S, right, equal to the 1.00 meter. So this is the object distance, and we want to find the S palm. And then the focal length of the lens of the converging lens is the 80 centimeter, which is equal to the 0.800 meter. It must be positive, right? For the converging lens, we have the positive F. So now from equation 1 over S plus the 1 over the S palm equal to the 1 over F. So let's just plug in the number 1 over the 1.00 plus the 1 over the S palm, and then equal to the 1 over the 0.800. So then finally we can just solve for the S palm, right, to be plus the 4.00 meter. Okay, we have the S palm to be positive. It means that the image must be on the same size as the refracted light. Okay, so the incident light is on the left hand side and the reflected light is on the right hand side of the lens. So it means that the image here will be on the right hand side of the lens as well. 4 meter, the 4 meter should be somewhere, I don't know, maybe, okay, let me just continue drawing the line here. Okay, the 4 meter should be somewhere 1, 2, 3, should be somewhere here. Okay, somewhere here. Okay, the 4.00 meter, right? And this will be the image. Here, the first image from the lens. Okay, so let's calculate the lateral magnification M1 for the first lens. M1 equal to minus the S palm and then over the S equal to minus the S palm is just the 4.00 and the S is the 1.00. So we have that the M1 equal to the minus the 4.00. It means that the image, from the lens, right, it's going to be the inverted because we have the negative sign here, and it's going to be larger than the object by 4 times. Okay. So now let's consider the mirror. Okay, let's consider the mirror. Again, for the S equal to. So you can see that the image, right, is going to be at the distance the 3.00 meter from the mirror. Okay, because this is 1 meter and the total is 4, so the left is 3 meter. But then, okay, if we consider, the path of the light, it will just go to the mirror. So this is the incident light, and then it will just reflect it back, right? So now you can see that the object, so this image is going to be the object for the mirror. So now this object is on the right hand side, and the reflected light is on the left hand side. Okay, it means that the the object is on the right hand side of the mirror, and then the incident light, this one, is on the left hand side of the mirror. So both of them are just on the different sides. It means that this is the virtual object. Okay, this can form the virtual object. So if we have the virtual object, it means that the S equal to minus the 3.00 meter. Okay, don't forget that for the virtual object, the S is negative. Then we want to find the S palm, right? We want to find the S palm. And then for the F of the convex mirror equal to minus 50 centimeter, so equal to the minus 0.500 meter here. Okay, again, so then again, let's use this equation. We have 1 over the S, right? And then plus the 1 over the S palm equal to the 1 over the F. The F is minus 0.5. Okay, so now with this you can get that the S palm is going to be equal to minus 0.600 meter. This will be the S palm minus 0.600 meter. It means that, okay, we have the negative sign for the image distance, right? It means that it will be on the opposite side as the reflecting light. So as I mentioned before, the light will just come from the left of the mirror and then reflected back of the left hand side of the mirror as well. So it means that the image will be formed on the right hand side at the distance 0.6 meter from the mirror. So this distance, it should be somewhere, let me use the gray one. Okay, it should be somewhere here. Okay, it should be somewhere here. So this one is going to be the second image. This will be the image from the mirror. Okay, and then this distance is going to be equal to the 0.600 meter. Okay, so let's compute the lateral magnification from the mirror. We have minus, okay, the S palm is minus 0.600, right? And then over the S is minus the 3.00. Okay, so then we have the M2 here equal to minus, okay, 0.200. Then finally the light will just go past the lens again. Okay, so let's see, S palm and then the F. So now for the S, right, the S. Okay, so now you can see that, the light will just go from the light the right hand side of the lens and then to the left hand side of the lens, right? And now this image will form the object of this lens. So you can see that the object is on the same size as the incident light, so the object distance must be positive. Okay, and then what distance? So now from this to this is 1 meter, and now from this to this is 0.6 meter, so the object distance is the 1.6 meter. So we have the plus the 1.60 meter here. Okay, so we just want to find the S palm. And now for the F again equal to the 0.800 meter. Okay, from this equation, we have the 1 over the S plus the 1 over the S palm equal to the 1 over the F. So then we can just solve for the S palm, right? Then S palm here equal to 1, okay, equal to plus the 1.60 meter. Okay, we have the image distance to be the positive. It means that it will be on the same size as the refracted light ray. So now you can see that the reflected light ray is on the left-hand side of the lens. So it means that this image, right, will be on the left-hand side of the lens as well. Okay, so it should be somewhere. Let me use this one, this color. Okay, it should be somewhere here, 1.6. Should be somewhere here. Okay, so now this is gonna call the final image. Okay, so this is gonna form the final image, and the distance is the 1.6 meter from the lens. Okay, the 1.60 meter from the lens. Okay, let's compute the magnification. Let's say the M3 equal to minus the S palm, and then over the S, right? The S is the 1.60 as well. So the magnification is just equal to negative 1.00. Okay. So now for the part B, we just want to determine the overall magnification of the image, right? Identify image is upright or inverted. Okay, so let's say that the overall magnification is the M1 times the M2 and then times the M3. The M1 is minus the 4.00, the M2 is minus 0.200, and the M3 is minus the 1.00. Okay, so the final is minus 0.800. That's going to be the answers for the part B. Okay, and I forget that this will be the answer for the part A. So we have this negative sign. It means that the final image, right, is going to be, let's say, it's going to be inverted. Okay, inverted, and then smaller size. It's going to be inverted and smaller size. Okay, so now, okay, if we go back to this picture, right, we can draw to be like, okay, so it's inverted and smaller by 0.8. Okay, so let's say that if this one is 1, then we have that it should be less than like this. Okay, and this will be the image, and that's it. So this will be final